Well, time to figure out how to get this thing open so we can extract the juicy stuff inside, I guess. I tried playing around a little bit with trying to pry that up, and I've seen videos of people doing things like trying to cut them open or pry them open or all that, but I'm thinking to myself, I don't really need to go through that trouble because all I really need to do is just crack the case open. So what I'm going to try to do here is to try and see what happens with a battery versus a vise. And hopefully this will be a not too messy approach. I say hopefully. That's not actually as easy as it seems. But let's see whether that actually did anything for us. I'll certainly push that in, but I don't know if that did that much else. So I think what I'm going to try to do is to just squeeze it down more like this. We'll see whether or not that makes a difference. Don't mind the squeaky table. Maybe this isn't going to take something with a little more effort to it. Looks like something's starting to happen there. I don't quite know what, but let's see. I think all I managed to do is make a square battery here. Yeah. Well, not much luck on that yet. But I'm gonna try and see whether maybe I can exploit some metal fatigue and start squeezing it on the opposite side. And if not, you know, I'll have my own special brand of square AA batteries, right? It seems a little more compliant, but not by much. Alright, maybe this really is not going to work the way I was thinking it was. I was hoping it would. But it doesn't look like it. That's just, maybe not. Might want to take the hammer to it or something. Just trying to see if I could do this in a way that wouldn't be so messy. But let's see. Give it one more try the other way. See if that makes any difference. But soften this up enough. It's probably the electrolytes inside that are causing issues with this. Alright. Well, guess that's not really doing anything. I mean, getting it mashed down nicely, but not much else. I might have to move on to trying to use the hammer on it. Well, that's what we're going to give it a try. And if we're going to do a hammer, might as well do a big one. Let's see what happens. That seems to be aside from making random bits of stuff fly out. There we go. That's starting to look good. Alright, you can actually see even a little bit of the zinc oxide that's getting squeezed out. So I don't really need to be that careful about dividing up the magnesium oxide or manganese oxide and the zinc oxide in there, because I'm going to use some differences in solubility to get them extracted. If I wanted to be a little more careful about this, there would be some ways that I could do that wouldn't require those separations as much, because the zinc oxide is already physically separated from the manganese dioxide by a piece of paper. But I was thinking that this was going to be a big hassle if I had to use, like, say, a Dremel tool or something to open this, which was looking like the other viable option. Say the jury's out on whether this is the better approach or the Dremel tool would have been better. But I think it's pretty much ready to give up the ghost here. I might need to use a screwdriver or something to help that along. Okay, so let's see if we can just pry open that a little bit more. Just get that metal to completely break, but I don't know. It doesn't look like it necessarily wants to. But I think at this point it can at least get to everything, so that's probably less of an issue. So nice if I could just split that little bit down there, or just let everything out like that. So I don't know, I guess this calls for a little more whacking on this. Can maybe get that tear to continue itself or not, I don't know. Incidentally, don't do what I'm doing here, because there is potassium hydroxide in this, although it's a dead battery, so it probably is used up for a large part, maybe, but I'm going to wash my hands after I'm done with this, because I don't really want to get chemical burns on myself. The zinc oxide and the manganese oxide should be fine, but the potassium hydroxide's not necessarily going to be that nice to you. Boy, it's kind of warm, but I think that's more because of the pounding on it with a hammer than anything else. Alright, I think I'll do a little bit of off-camera cleaning on this and get this, and also wash my hands and get this thing collected up here. I'll tell you, this battery casing is pretty hot. So what that tells me is that, one, this battery probably was not totally discharged, and the other part of it is that I very much doubt that that was from pounding on it with a hammer, because it's seeming to get hotter. So it was probably just a reaction from the ingredients in the battery, which is why I said I suspect it probably wasn't fully discharged. Why it was no longer working well in my mouse, I don't know, but that's a subject for a different day. And what I want to be able to do is, if you see all this kind of like whitish gray stuff here, that is the zinc oxide. If it's more of a kind of dark gray, silverish color, then that would be the original zinc powder. So I do think the battery was mostly used up, but probably my mechanical encouragement got some chemicals mixed together that weren't going to do so efficiently in the original form of the battery. Don't know that that's of much use because it would just heat things up, but that's what we can do with that. All right, so what I'm going to do with this is I'm going to mix in some water, and I'm going to use that to try to dissolve out the potassium hydroxide that's in there, and that will, the zinc oxide, leftover zinc, and the manganese oxides will not dissolve in the water, so the only thing that's going to dissolve is just the potassium hydroxide, which I want to get rid of. Okay, so I'm going to add a little bit of the distilled water here. And I don't think I need to put that much in, because the reality is I'm only really trying to just get this to be a little bit just wet enough to be able to get rid of the potassium hydroxide. What I'm going to do with this afterwards is I'm going to just filter out the water, and then I'm going to react it with some citric acid. And the citric acid will go after any free zinc as well as the zinc oxide. I've tried this before and it doesn't really do much to the manganese oxides. I think they're just not as reactive. So that actually works out well because it means that I can get a can do some separation by solubility at that point. And the zinc acetate is what I'm going for. There's going to be a little bit of an irony to this because theoretically, if this is a fully depleted battery, then it should be all zinc oxide. I'm going to change that zinc oxide into zinc citrate, and with the ultimate goal of actually turning it back into zinc oxide. But the logic behind it is, again, it makes it easier for me to separate. And the other thing that it does is it makes it easier for me to be able to put that down as a thin film, which is what I'm going to be aiming for with this. Nothing says high quality chemistry better than a coffee filter and a plastic cup, but it'll do the job. And I got a lot more in the container still that I think I want to get over there. I think a lot of this is more the manganese oxides than the zinc oxide. And trying to think of what I can do with the manganese oxide. I know there's like permanganate that I could make, which is a fairly safe and powerful oxidizer, so I don't know, might be worth looking into that, but I think for right now I'm just going to treat that more as a distraction, and that I don't want to bother doing with that. So I'll just let this stuff settle down there a little bit. I'll wash out that container with a little more distilled water just to clean it up and get rid of as much of the stuff in there as I can. Just a little bit more, and then we will wait. All right, so now we got all of the solids separated out, or for the large part. And since what I'm going to do is use some citric acid in this, I think actually I'm going to just go ahead and leave it in the coffee filter because the citric acid isn't going to do anything to that anyways. And then I'm going to just add a little bit of water in there and just let it go that way. Seems to me like there's no really good reason to lose material by trying to scrape it all off of the paper there, since I'm going to try to solubilize the stuff I want. And, nicely enough, citric acid is something that one can get very easily for canning supplies and such. So we will just put a little bit of that in there. The only real risk of putting too much in is that it's going to be soluble as well. And so it might be something I could mistake for the zinc oxide. That, by the way, is not exactly the kind of thing you want to breathe in all the time. But add a little bit of water in there. And if we see any bubbling, that's going to be an indication that there was some zinc that was left over. And so that's more likely than not what's going on there. I'll pour some water up from the back side there and just let that go. I can see a color change in there, and so I'm kind of guess that that might be some indication that the zinc is starting to dissolve there. I also do see some bubbles forming, and so my guess is, like I said, that's probably leftover zinc. The zinc oxide would not bubble because all that's going to do is just turn into, the citric acid. The proton on the acid will react with the oxygen on the zinc oxide and produce water. The zinc, on the other hand, would simply substitute for the proton, and what you'd end up with is basically hydrogen gas. So that's what's going to happen on that. And then we'll just basically let that go. Frankly, the reaction ought to be fairly fast, but we'll just let it sit for a while and then see if we can let it diffuse out of there anyways. So I'll give that some more time to just cook there. You can definitely see a change in the color. I'm going to have to look that up and see whether that's any possibility that it's the manganese oxide maybe changing its oxidation state or something. Because I don't think the zinc oxide by itself would be white, and I think the zinc acetate would be as well. So I don't think that that's an indication of something going on with the zinc. So it's probably doing something to the manganese oxide. Hopefully, if it is, it's not turning into something soluble. Well, this right here was a fail. You can see that we ended up with some brownish water here, and I did get what appears to be most of the manganese dioxide and probably still a little bit of the zinc oxide based on the white stuff in there. But I was thinking to myself, well, what happened here? Did some of the manganese actually become manganese citrate? And that's possible, but what I suspect actually is, after reading this a little bit, I guess there's some iron that's in the manganese oxide. Don't know whether it's actually coming from the shell of the battery or what, but that's what this might be here, because I mean, either or could be manganese oxide. So I'm going to have to take a different approach to taking apart the batteries and make a better effort to physically separate the zinc oxide from the manganese oxide before I try doing this.